Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Civil Point. It's Abdullah Maqsood. Today we are going to study about design aids, means that how to read or inch, pound or system international designation, diameters, areas and weight of standard bars. So it's very simple, but we should have knowledge about it. Firstly, we have this table A1. It gives us information regarding designation, diameter, area and weight of bars. This table is of inch pound system, but it will also give you designation in system international. So firstly, in first column it has inch pound designation from 3 to 18, 3, 4, 5, 6 and 3 to 18. In second column its equivalent system international bar designation. For example, in inch pound system, number 3 is a standard bar number and same equivalent number is 10 in system international. So it will carry on like this. In third column there is diameter will be in inches. You have to divide inch pound designation number to 8 to get diameter inches. For example, you will divide 3 to 8 and you will get 0.375, which will be the diameter, and then you will get 4 divided by 8 or 1 divided by 2.5. So this will be the diameter in inches. The third column will be the cross section area. Simply you will have to do, what you will have to do is pi d square by 4. This will be the formula because bars are in circle. So this will be the d. Pi value is 3.14. You will put d, for example, diameter is 0.75, 0.75 square divided by 4 and you will get its area, which is 0.44. So we will calculate this area, but during design of beam or column or any structural element, you don't have enough time to calculate individual bar area. So you will use this table A1. At the end, in the last column, you will have nominal weight in pound per feet. Means that how much weight it has in per feet. So we can say that in inch pound, number 4 dia has 0.668 pound per feet weight. So this was a simple table for design purpose. You will use this one in the design of structural elements. So we are moving forward towards another table. This one is the table A4, which is limiting steel reinforcement ratios for tension control member. This table will be used for tension control members in which tension is important. For example, you are designing a beam and you have to know about the maximum reinforcement and minimum reinforcement. There will be a question in your mind that how much reinforcement is the limit for this beam and how minimum reinforcement is it would be the minimum limit of this beam. For example, this is max and this is minimum. You will have to use reinforcement between these are included. You will not have to go beyond this and you will not have to go beyond this. You will place balance reinforcement in it. So let's suppose you have a limiting value for it. This is rho maximum reinforcement ratio, and this is minimum reinforcement ratio. What you will provide is between this and this. These two are also included in this limit. You will not cross these limits. For example, you will not provide less than minimum reinforcement in your beam and you will not provide more than maximum reinforcement in your beam. So how will you get that? Firstly, you will see there is Fy, mean the yielding strength of your reinforcement. So if you are using 40 grade, you will use this one, 40,000. If you are using 50 grade, you will use 50,000. And if you are using 60 grade or so on, you will use remaining. So for example, I'm using 60 grade. My yielding strength for reinforcement will be 60,000. Then the second thing is FC prime, mean our compressive strength of concrete. So we have 3,000, 4,000 and so on. If I'm using 60,000, we will not use these values, we will use these values. Let's suppose I have 3000 psi, pound per square inch of compressive strength of concrete. So I will use this, and these are the default values of beta. And then I have to I want to know about the maximum reinforcement, minimum reinforcement of beam limiting values. So I will use this one, and this one. These three columns will be used for this purpose. This column will give us the maximum value, how much value will be maximum for our beam. So this is rho maximum. So I'm here, this one will be the maximum reinforcement value of rho for my beam. So how I will use this? I will use this like 0.0155. This will be the rho maximum value of my rho. And let's suppose I have a beam of 12-inch width, and 24-inch depth. So how I will use it? I want to know about the reinforcement, exact reinforcement in inch square. So we know that area of steel is equal to rho into B into D. So I will put this value 0.0155 multiplied by B. What is B? B is the breadth of beam, which is 12 inches, multiplied by D. This one is H. So 24 minus 1.5 cover of my beam will be 22.5. So by calculating this value, I will get my area of steel in inch square, because these values are in inch. So this area will be the maximum area that I can put in my beam. So this was the maximum reinforcement. Now we have two formulas for the minimum value of my reinforcement in my beam. First one is rho minimum is equal to 200 over Fy. Second one is 300 over Fc dash over Fy. I have already told you Fy is the yielding strength of steel. Fc prime is the yielding strength of concrete. So by calculating these values, these are the minimum values for our beam. We will use maximum value from these two in our beam. Let's suppose we have, from the same we have 0.0033 from this formula and 0.0027 from this formula. We will use this one for our minimum, and in the same way we will calculate this by putting our rho minimum value at this point, and we will get our minimum value of steel, which will be put here. So this was a simple lecture about limiting steel reinforcement. Now we are moving forward.